So now as we can see that it has given its output that there are 551,516,309 datasets currently present on the hub. Okay, so now from these number of datasets we are going to load the emotion datasets. Okay, so we are loading datasets from datasets. We are importing the dataset class from the dataset library, right? Okay, now in this line of code what we are doing, we are creating the emotions variable to store our dataset. From the dataset load dataset, we use the load dataset function to store this emotion data into emotions variable. Okay, so now let's even see this emotions dataset out. How does it look like? Okay, so it is loading it. So as we can see that this data set contains the train data set, a validation data set, and a test data set. If you are not familiar with what is train data set, validation data set, test data set, don't worry, I'll tell you what is it. The train data set stands for the data set on which it is trained. The validation data set in which it is cross-checked, and finally we have test data sets in which the accuracy of the training is tested. Right. So as it is visible, the data sets, it's pre-processed into train validation test data set. And if we don't have data set in this format, then we have to pre-process the data set into this format. Right. We have to separate the data set into train, validation, and test. That's a part of some another pre-processing discussion. Okay. So now let's see that what is the training part of data set. How does it look like? So I used accessing the training part of the dataset, right? So this dataset contains two features, a text and a label. Okay, so if I want to see that how does it look like, so let me input another cell and I will say that train ds0. By this code, I will access the first line of the data that we have, right? So let's run it and see how does it look like. And it has 16,000 number of rows of data, right? So it's a pretty good amount of data when we want to train a classify. Is it running or not? Okay, similarly we have this validation data set also, then we have this test data set also. So firstly we have text, I didn't feel humiliated, label 0, and then again text, I didn't feel humiliated, label 0. For some reason, I don't know, it has given me two line of outputs, right? So this label probably gives us the type of emotion that it is showing. The label 0 probably will have some emotion that will be mapped later. So we will see that how does this label gets mapped to some emotion. If there will be label 1, it will map to some another emotion. If there will be label 2, it will be mapped to some another emotion. So you will see that later. Similarly, we have this validation data set. We have this test data set. Each of this contains 2000 number of rows. Okay. So let's first look at train data set that I have already processed this code. Now let's see the first 10 lines of the train data set. So we have this, I didn't feel humiliated. These are the text that we have, and these are the associated labels which with each of these text. Okay, so the last line that I feel romantic too, it has the second label. Okay, so now if I will see the print, let's see that what are the features that train dataset has. Okay, so firstly it has the text, that is value of string. This is the text, and then it has the corresponding label. Okay, and in which the class label are these. Okay, so the sadness is associated with the label 0, joy is associated with the label 1, and so on, right? So as we can see that I feel romantic too, this is the last line, and the last label 2, it is associated with the second 0, 1, 2, the number 2 label, that is love, right? So this is how we have our data set, and this is the data that we should work on. If data set is not in this way, then we will need to convert it into this way, right? Now let's convert this data set into data frame. We have imported the pandas library to import the pandas library so that we can see it in a better form, in a table format. Okay, so for that pandas is used, and we will convert this emotions data set into the type of pandas, so that we can if you won't do that, then you will get an error. You can see that what error that we will get. I converted this data frame I used an data frame instance to convert this into a data frame, and then finally I have used a data frame dot head command that will give us the first 5 rows of this data frame. Okay, so let me show you that what does this set of command do. So I used this, I converted into a pandas data frame, so that it was like we were getting this display like this. Now we are getting a display like this, and it is a much better format that I didn't feel humiliated. Is correspond to the label 0, and label 0 correspond to the sadness. I can go from feeling so hopeless to be damned. Okay, so this is again the speaker is sad. Okay, so this is the data set that we have. Okay, looks good, but for our training purpose, we'll need that the text should be mapped to the emotion, not the label. Okay, so now we have seen like, okay, so text is mapped to some label, but I don't want this. I want that this text should be mapped to the text of the label, right? It is because of two reasons. Why? Because we know that transformer converts this text into some encodings, and it will also convert this label into some encoding. Right now, if I say that I didn't feel humiliated and I will map it to sad. Now, sad and happiness will have some, sadness and happiness will have some different association with sadness, and joy will have some different connection with each other when we correspond it to some text. But the 0 and 1 label will have some another connection. Okay, so when I will input 0 and 1 into the transformer encoder, it will process it in some other way. But when I will input the sadness and joy, then it will be more beneficial for us, because we don't want it to connect the label 0 with the 1 digit. I want it to connect sadness with joy. I don't want it to connect 0 to 1. Okay, so it will look like that. Okay, 0 is very close to 1, so it may be seen that okay, sadness is very well connected to joy, but that's not really the case, right? So what will we do? We will don't use the label as this. We will use the label as these text, right? So let's map it to that. We will use a def label. I just defined a custom function for this function so that we can get each label with the corresponding text, right? So now we have label, and also we have the label name, right? So now it looks good. Let's see that how much data we have. It's always a good thing to see whatever data set has. Like, okay, so we have sadness, we have anger, we have love. Okay, we have different type of emotions, but what percentage is sadness, what percentage is anger, what percentage is love, right? So I use a matplotlib library to get this frequency table, this bar plot. Now see that this data, it is actually very unbalanced data. We have very much data for joy, but very less data for surprise. So we need to understand that the whatever prediction we will do on this data set, it will be more skewed towards the joy, right? It will think that most of the part the speaker is joyful. Okay, so if it is not getting much of the sadness, much of the surprise words in it, it will give the prediction of joy to it, right? I guess I am you are understanding well. Okay, so data set seems very unbalanced. Okay, so let's work with this data set. Now we are going to tokenization. Okay, so I said about something like this, right? That what is tokenization, tokens. Okay, so sunrise paints the sky with gold. Like, the transformer cannot process the whole sentence at once. Okay, so we need to break it down. We need to tokenize it. Now, tokenize is actually the core part of NLP, right? Okay, if I will say tokenization. Tokenization is one of the most important part of the and decision-making part of the NLP, right? Because why is it so? Because whenever we tokenize a sentence, we break its meaning, right? We break, like if we are tokenizing a sentence into some haphazard way, if I'm breaking it in some haphazard way, then the encoder will not be able to get the good relationships between it, right? So that is why for particular DistilBERT, we use the tokenizer that DistilBERT uses. Okay, it's always good that when we are working with some model, we use the tokenizer that is associated with that model. Okay, that is more like if I'm saying something in if my model is, if you have understood the English language, but I'm teaching you it in Hindi language, you won't understand it well. Okay, so whenever this DistilBERT model is trained, it is trained with some particular tokenizer. So that is why it is good when we are using it, we use the same tokenizer. If we won't use that same tokenizer, it won't be able to associate the meanings very well on which it was trained previously. Okay, so that is why from I importing the auto tokenizer class from transformers. Okay, so we for the model, what is DistilBERT base uncased? Okay, so this is the particular model that we are going to use. Okay, so what happens is that whenever when this DistilBERT was trained, DistilBERT was trained, so there were particularly weights and features that came out to be the result. Okay, so these are the particular weights that we are going to use whenever we want to get out with this BERT. So those all weights are stored in this model CKPT file, that is this. Okay, right? So now we are going to use the tokenizer that is associated with this pre-trained model, that is model CKPT. Okay, so using the specific tokenizer with the associated model, right? Let's just see how the tokenizing. Okay, so let's see an example that how the tokenizing is happening. If we have this text, let's do tokenization in NLP, classic mistake. Transformers are great. This is the sentence that we want it to get tokenized. Okay, so I run this code. The text variable has this sentence now. It has this string. Okay, so firstly, this text, whenever I will parse this text into this tokenizer, it will get encoded into some numbers. Now let's see, and then we print these numbers to see what we get as output. Okay, so name tokenizer is not defined. That means we have not run this cell. Run it. Okay, so now what will happen? It will download from the Hugging Face this model, and it will take some amount of time. So we can wait with that time, right? Like these bars are these bars show that it is being downloaded, right? So it has run, and we have the tokenizer now. Let's run this then now. Okay, so now what is it? As you can see that this text gets converted into these numbers. Okay, and there's also some attention mask. Okay, what is it? Let's see. Now each of the above encoding ID is mapped to a token. Okay, so how is this text converted into this numbers, and what does these numbers mean? Does these numbers have some special meanings? It's not. Let's see that. Okay, now each of the above encoding IDs mapped to a token. Let's convert each of the IDs to a token. Basically, this 2292 will have a word stored like let. Let's see how it is done. Okay, so these are the text. These whenever this transformer will be would have trained now. So what would have happened? It would have connect this 101. Let me do one thing. Okay, I'll do it later. This 2292 with the word let. Okay, so this 2292 got converted to let. This 101 got converted to the CLS. This 1005 got converted to this apostrophe. Okay, so let got converted to 2292. This apostrophe got converted to 1005, and then this S got converted to the 1055. So in this way, the corresponding IDs that would have been stored when the model was being trained, now the tokenization has converted this sentence into those IDs so that it can process it and it can understand. So basically, this text is being converted to some ID that this transformer can understand. I hope I'm clear in words. Right, so these were the tokens, and what is it that I can see that this token, and then the tokenization, this tokenization word has been you can say broken down to two parts, and then this is double hash. So this double hash shows that this before this word there was not space, it was some other part of string, right? So this token word would have some part of ID, so it got that ID, so it got converted into that, and then it converted this ization into some another ID, right? So this is how the tokenizer does the tokenizing, right? So this was tokenization. Let's see now let's convert this sentence back into string. Okay, let's concatenate into back into string. So we got the same line. All okay, not so perfect that there is extra space there, but it got converted into back, right? Now what is this CLS and what is this SEF? CLS shows that the tokenization is being started, and this SCP shows that this is the end of the tokenization, right? Okay, so this was about tokenization, that whenever we start tokenization, then it starts with CLS and it ends with SCP. CLS, the corresponding CLS, the ID of CLS is 101, and the corresponding ID to the SCP is 102. So that the model can understand, okay, so the string has ended, and by CLS it will understand that the string has started. So then we have the features for tokenization also, that the vocab size for tokenization, model max length, how much the maximum length can model can have, it's 512. And okay, so now what is this tokenization model input names? That tokenizer, what are the input names in the tokenizer? It has input IDs and the attention mask. As you can see that when I printed this encoded text, it gave me input IDs and it also gave me attention mask. What is the attention mask? Attention mask just shows 1 1 1 1 1 1 1. Okay, what is it? Let's see what is it.